What if I told you that right now, at this very moment, an object from beyond our solar system is doing something that shouldn't be possible? Something that's making astronomers question everything we thought we knew about interstellar visitors? On September 27th, 2024, Comet 3I Atlas began exhibiting behavior so bizarre, so unprecedented, that it's forcing us to rewrite the rulebook on what objects from other star systems can do. Here's what's happening. This comet, confirmed as only the third interstellar object ever detected entering our solar system, started erupting with explosive outbursts that increased its brightness by over 100 times in a matter of hours. But here's where it gets truly insane. Unlike any comet behavior we've ever witnessed, these eruptions aren't following any predictable pattern. They're chaotic, violent, and completely unprecedented. And the implications? They challenge our fundamental understanding of what interstellar objects are made of, how they behave, and what this means for the larger universe around us. Think about this for a second. We've been watching comets for thousands of years. We have mountains of data. We can predict their behavior with incredible accuracy. But 3I Atlas is breaking every rule. It's as if the universe just sent us a visitor that operates on completely different physics, and we're scrambling to understand why. Dr. Daryl Seligman from Cornell University, one of the leading researchers tracking this object, said something that should make your spine tingle. He stated that the volatility and intensity of these outbursts suggests this comet may contain chemical compounds and ice mixtures that simply don't exist in our solar system. We're looking at chemistry from another star's planetary system, and it's nothing like home. Before we dive deeper into this cosmic mystery, I need you to do something. Hit that like button right now and subscribe, because what I'm about to reveal over the next few hours will fundamentally change how you see our place in the universe. Also, drop a comment telling me what country you're watching from and what time it is there. I'm genuinely curious how this cosmic story is spreading across our planet while we discuss objects spreading across the cosmos. Now, let's rewind for a moment and build the foundation you need to understand why what's happening to 3I Atlas is so monumentally important. To appreciate the insanity of this situation, you first need to understand what makes an object interstellar and why we've only confirmed 3 of them in all of human history. Picture our solar system as a neighborhood in a vast cosmic city. Our sun is the center, and everything orbiting it, every planet, asteroid, and comet was born here. These objects are our cosmic neighbors, formed from the same disk of gas and dust that created our sun about 4.6 billion years ago. But interstellar objects? They're visitors from other neighborhoods, other star systems, traveling through the vast emptiness between stars. And here's the mind-blowing part. Space is so incomprehensibly large that even though there are hundreds of billions of stars in our galaxy, the distance between them is so vast that interstellar objects almost never visit. Almost never. Let me put this in perspective with an analogy. Think of it like this. If our sun were the size of a ping pong ball sitting in New York City, the nearest star would be another ping pong ball in Los Angeles. Everything in between? Empty space. Now imagine trying to throw a grain of sand from one ping pong ball and having it reach the other. That's essentially what an interstellar object is doing. It's crossing unimaginable distances, and the fact that we've detected even 3 of them is absolutely remarkable. The first confirmed interstellar visitor was one High A Oumuamua, detected in October 2017. When astronomers first spotted it, they thought it was just another asteroid. But then they calculated its trajectory, and their jaws dropped. This thing was moving way too fast to be gravitationally bound to our sun. It was just passing through, like a cosmic tourist taking a quick detour through our solar system before heading back out into the darkness. But Oumuamua was weird in other ways too. Its shape was bizarre, elongated like a cigar or perhaps a pancake. We still debate this. and it accelerated in ways that couldn't be explained by gravity alone. Some scientists, including the respected Harvard astrophysicist Dr. Avi Loeb, suggested it might even be artificial, though most astronomers attribute its strange acceleration to outgassing, like a comet. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from his personal observatory in Crimea. Unlike Oumuamua, Borisov looked and acted like a comet we'd recognize. It had a tail. It was outgassing as it approached the sun, and while it was definitely from another star system, it wasn't breaking any rules. It was comforting, in a way. It told us that at least some things out there behave like things here. But now we have 3I Atlas, officially designated as C2024-S1, detected first on September 27, 2024, by the Atlas Survey System in Hawaii. And this thing? This thing is rewriting everything. The detection itself was remarkable. ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, uses robotic telescopes to scan the entire night sky every night, looking for anything that moves or changes. When 3I Atlas first appeared, it seemed like it might be another typical long-period comet. But within days of its discovery, astronomers at the European Southern Observatory and NASA's Jet Propulsion Laboratory calculated its orbit and realized something shocking. This object was moving at over 60 kilometers per second relative to our Sun, and its trajectory was hyperbolic. In plain English, that means it has enough speed to escape the Sun's gravity completely. It came from somewhere else, and after its brief visit through our solar system, it's heading back out into interstellar space, never to return. Now here's where the chaos begins. Within 2 weeks of its discovery, 3I Atlas started erupting. And I don't mean gentle outgassing like a normal comet. I mean violent, explosive outbursts that increased its brightness by factors of 100 or more in just hours. Dr. Michelle Bannister from the University of Canterbury in New Zealand, who has been tracking this object obsessively, described these eruptions as apocalyptic. Her team measured outburst events where the comet expelled more material in 6 hours than typical comets expel in months. Think of it like this. Imagine you're watching someone breathe normally, steady inhales and exhales. That's a regular comet approaching the sun, gradually heating up and releasing gas in predictable patterns. Now imagine that person suddenly starts coughing so violently that they're expelling hurricane-force winds from their lungs every few minutes, completely randomly, with no warning. That's 3I Atlas, and we have no idea what's causing it. What makes a comet erupt like this? To understand that, you need to understand what comets are made of. Regular comets from our solar system are often called dirty snowballs, a term coined by astronomer Fred Whipple in 1950. They're mixtures of water ice, frozen carbon dioxide, frozen methane, ammonia, and rocky dust particles. As a comet approaches the sun, these ices heat up and sublimate, meaning they go directly from solid to gas without becoming liquid first. This outgassing creates the spectacular tails we associate with comets, glowing trails of gas and dust that can stretch millions of kilometers through space. But the outgassing from normal comets is relatively predictable. We can model it. We understand the physics. As the sun heats the surface, the ices underneath vaporize and escape, carrying dust with them. Sometimes, if pressure builds up under a crusty surface layer, you get more explosive outbursts, but even these follow patterns we can anticipate. 3I Atlas is doing none of this. Its eruptions are chaotic, asymmetric, and far more violent than anything the amount of solar heating it's receiving should produce. Here's what will blow your mind. Dr. Seligman's team ran computer simulations trying to replicate 3I Atlas's behavior. They tested every known mixture of ices and volatiles we've ever detected in comets. Water ice, carbon dioxide ice, methane, ammonia, nitrogen ice, every combination. And here's the kicker. Nothing matched. None of the models could reproduce the intensity and randomness of these eruptions using materials we know exist in our solar system. The conclusion? 3I Atlas must contain something exotic, some mixture of chemicals that formed under conditions completely different from anything in our cosmic neighborhood. Think about what that means. This comet formed around another star in a protoplanetary disk with different chemistry, different temperatures, different pressures. It's a chemical time capsule from an alien solar system, and it's literally exploding in front of us, showing us its guts. We're witnessing the death throes of an interstellar wanderer, and in its dying gasps, it's teaching us about a place we'll never visit. Let me give you another analogy to make this concrete. Imagine you've lived your entire life in a small village where everyone cooks with the same 5 ingredients: salt, pepper, flour, water, and oil. Then one day, a traveler arrives from a distant land you've never heard of, and they start cooking a meal. But as they cook, the pot starts bubbling and erupting in ways you've never seen. Colors you don't recognize. Smells that don't make sense. The chemistry is all wrong. That traveler is using ingredients that don't exist in your village, operating with culinary rules from a completely different food culture. That's what 3I Atlas is doing. It's cooking with alien ingredients, and we're trying to reverse engineer the recipe by watching the pot explode. Now, you might be wondering, how do we know these outbursts aren't just normal comet behavior that we've somehow misunderstood? Great question. The answer lies in spectroscopy, one of the most powerful tools in astronomy. When light passes through a gas, that gas absorbs specific wavelengths, creating a unique fingerprint. Every element and molecule has its own signature pattern of absorption lines. By analyzing the light coming from 3I Atlas's eruptions, astronomers can identify what chemicals are being expelled. And here's where it gets even stranger. The spectra from 3I Atlas show absorption lines that are difficult to explain. There are hints of carbon monoxide, which isn't unusual for comets. But there are also features suggesting the presence of highly volatile ices, like nitrogen and carbon monoxide, in ratios that don't match solar system comets. Even weirder, there are organic compounds, complex carbon-based molecules that appear to be more diverse than what we typically see. Dr. Bannister's team detected signatures suggesting the presence of long-chain hydrocarbons and potentially even amino acids, though confirming the latter requires more data. Do you realize what this implies? Amino acids are the building blocks of proteins, the foundation of life as we know it. If 3I Atlas is carrying amino acids from another star system, it means the chemistry necessary for life isn't unique to our solar system. It's out there, scattered across the galaxy, hitching rides on interstellar comets. And every so often, these cosmic delivery vehicles crash through star systems like ours, potentially seeding planets with the ingredients for life. This brings us to one of the most profound questions raised by 3I Atlas. Could interstellar comets be the mechanism by which life spreads through the galaxy? This idea, called panspermia, was proposed by scientists like the Nobel laureate Francis Crick and astronomer Fred Hoyle. The basic concept is that life, or at least the chemical building blocks of life, might not originate independently on every planet. Instead, it could be spread through space by comets, asteroids, and interstellar objects, floating between star systems and seeding worlds with the ingredients needed to start biology. For most of history, panspermia was considered speculative, almost fringe science. But 3I Atlas is making us reconsider. If this comet contains complex organic molecules, and if it's just one of potentially trillions of interstellar objects wandering the galaxy, then the ingredients for life are everywhere, constantly being redistributed. Earth itself might have been seeded by objects like 3I Atlas billions of years ago. Your existence, my existence, all of life on this planet might owe its origins to a chaotic interstellar comet that exploded in our solar system before life even began here. Let that sink in for a moment. You might literally be made of stardust that traveled across light years of space on a comet. Before that comet crashed into early Earth and delivered the molecules that would eventually become DNA, become cells, become consciousness, become you. That's not poetic exaggeration. That's an increasingly plausible scientific hypothesis, and 3I Atlas is providing evidence for it right now. But let's get back to the chaos. Why is 3I Atlas erupting so violently? One hypothesis being explored by Dr. Seligman and his colleagues involves superheavy ice mixtures. In our solar system, water ice is the dominant component of most comets because water was abundant in the protoplanetary disk that formed our planets. But in other star systems, especially those with different initial compositions or different thermal histories, other ices might dominate. Imagine a comet where carbon monoxide ice or nitrogen ice is the primary component, with water being just a minor contaminant. These superheavy ices have much lower sublimation temperatures than water. Carbon monoxide ice, for instance, sublimates at around 68 Kelvin, which is negative 205 degrees Celsius. That's incredibly cold. But here's the critical point. Once you get even slightly above that temperature, carbon monoxide ice doesn't just gently sublimate. It can undergo what's called a sublimation avalanche, where the release of gas creates cracks and fractures in the comet's structure, exposing more ice, which sublimates even faster, which creates more cracks in a runaway feedback loop. Think of it like popcorn. When you heat a popcorn kernel, the water inside turns to steam, building up pressure until the kernel violently explodes. Now imagine a comet-sized popcorn kernel made of carbon monoxide ice, and instead of heating it gradually, you're flying it past a star. Random regions heat up, trigger sublimation avalanches, and boom, you get these massive, chaotic eruptions. That might be what's happening to 3I Atlas. It's a popcorn comet from another star, and we're watching it pop in real time. Another hypothesis involves subsurface oceans. Yes, you heard that right. Some scientists speculate that 3I Atlas might have contained liquid water deep beneath its surface, kept liquid by radioactive decay of elements like aluminum-26 or by tidal heating if it was once part of a binary system. If that liquid water suddenly reaches the surface through a crack or fissure, it would explosively vaporize in the vacuum of space, creating exactly the kind of violent eruptions we're seeing. Dr. Alan Fitzsimmons from Queen's University Belfast has been modeling this scenario. His simulations suggest that if 3I Atlas has a subsurface ocean, even just a few meters below its surface, and if the frozen crust suddenly fractures, the pressure release would be catastrophic. Water would flash to vapor almost instantaneously, carrying with it massive amounts of debris and organic material. This could explain not only the intensity of the eruptions, but also the diverse chemistry we're detecting in the expelled material. Imagine that. An interstellar comet with its own ocean, traveling through the darkness between stars for millions or billions of years, finally entering our solar system and breaking apart, releasing its ancient water into space. That water might have been liquid when our sun was just forming. It might have been liquid when the first dinosaurs walked on Earth. And now it's erupting before our eyes, a cosmic time capsule from an alien ocean, revealing secrets about the history of another planetary system. Now, here's where we need to talk about the bigger picture, because 3I Atlas isn't happening in isolation. The title of this documentary mentions that space is erupting into chaos, and that's not hyperbole. In the past 2 years alone, we've detected an unprecedented number of unusual astronomical events that suggest our universe is far more dynamic and violent than we previously thought. In March 2024, astronomers detected the brightest gamma-ray burst ever recorded, designated GRB 240327A. This explosion was so powerful that it temporarily overloaded detectors on multiple satellites. Gamma-ray bursts are thought to occur when massive stars collapse into black holes, but this one was different. Its light curve showed oscillations and patterns that don't match our models. Some researchers speculate it might have been caused by a magnetar, a neutron star with a magnetic field trillions of times stronger than Earth's, undergoing a massive flare. Then in July 2024, the supergiant star Betelgeuse, which has been dimming and brightening erratically for years, underwent another dramatic dimming event, dropping to barely visible with the naked eye. Dr. Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics, who's been monitoring Betelgeuse for decades, suggested this might be the precursor to a supernova. If Betelgeuse explodes, it will be visible during the day for weeks, a cosmic spectacle that hasn't occurred since 1604. And it could happen tonight, tomorrow, or 100,000 years from now. We simply don't know. And now we have 3I Atlas, an interstellar visitor erupting unpredictably. 3 major cosmic events in 1 year. Coincidence? Maybe. Or maybe we're just getting better at detecting these phenomena. But there's another possibility that I want you to consider, one that's both thrilling and slightly unsettling. What if the universe is actually entering a more active phase, and we're witnessing the beginning of something larger? Our galaxy undergoes cycles. The spiral arms of the Milky Way rotate, and as they do, they compress gas clouds, triggering bursts of star formation. We might be entering a region of the galaxy where star formation is more active, where supernovae are more common, where the interstellar medium is more turbulent. If that's the case, we should expect to see more events, like what's happening to 3I Atlas. More interstellar objects passing through, more stellar explosions, more cosmic chaos. Here's a thought experiment for you. Imagine you're standing in a field on a calm day. Everything is quiet and still. That's been our experience of the universe for most of human history. Occasional shooting stars, a comet every few decades, but mostly a serene, unchanging cosmos. But now, imagine the wind starts to pick up. At first, just a gentle breeze. Then stronger gusts. Leaves start swirling around you. You realize a storm is coming. That might be where we are right now, cosmically speaking. The breeze is picking up, and events like 3I Atlas are the first leaves swirling in the wind. Let me ask you something, and I want you to really think about this. When you look up at the night sky, what do you see? Most people see stillness, constancy, peace. The same stars that your ancestors saw thousands of years ago, unchanging and eternal. But that's an illusion. The universe is violent. Stars are exploding. Black holes are colliding. Galaxies are tearing each other apart. And every so often, objects from these cosmic disasters pass through our little corner of space, reminding us that we're not isolated. We're part of a dynamic, ever-changing universe. 3I Atlas is one of those reminders. It's a messenger from the chaos, carrying stories written in ice and rock and organic molecules. And by studying it, by watching it tear itself apart, we're learning to read those stories. We're becoming cosmic archaeologists, piecing together the history of star systems we'll never visit, using the fragments that drift through our neighborhood. Now let's talk about the specific science behind tracking and analyzing 3I Atlas, because this is where the story gets really technical and really cool. When astronomers detect a new object in the sky, the first challenge is determining its orbit. This requires multiple observations over several nights, sometimes weeks, to track how the object moves against the background stars. For 3I Atlas, initial observations were made by the Atlas Survey in Hawaii, but within days, observatories around the world were pointing their telescopes at it. The process of confirming an interstellar origin is rigorous. You need to calculate what's called the orbital eccentricity, a number that describes how elongated an orbit is. A circle has an eccentricity of 0. The planets in our solar system have eccentricities between 0 and about 0.2, meaning their orbits are nearly circular. Comets from the outer solar system can have eccentricities close to 1, meaning their orbits are very elongated, but still bound to the Sun. But if an object has an eccentricity greater than 1, that means its orbit is hyperbolic, not an ellipse. It's not bound to the sun at all. It's just passing through. 3I Atlas has an eccentricity of 1.03. According to calculations by the Minor Planet Center, the organization responsible for cataloging small solar system bodies. That might not sound like much of a difference, but mathematically, it's huge. It means 3I Atlas came from interstellar space and is returning to interstellar space. Its closest approach to the Sun, called perihelion, occurred in late October 2024, when it came within about 0.4 astronomical units, roughly the distance from the Sun to Mercury. After that, it's heading back out, accelerating as it goes, eventually reaching speeds of over 60 kilometers per second relative to our Sun. But calculating the orbit is just the beginning. To understand where 3I Atlas came from, astronomers have to trace its trajectory backward in time, accounting for the gravitational influences of all the planets it passed near. This is insanely complicated, because even tiny gravitational tugs from Jupiter or Saturn can alter an object's path over millions of years. Nevertheless, preliminary calculations suggest that 3I Atlas originated from the general direction of the constellation Cassiopeia, which doesn't tell us much about its actual home star system, but it's a starting point. Here's what's mind-blowing about this. 3I Atlas has been traveling through space for potentially millions of years. Think about that timescale. When this comet was ejected from its home star system, anatomically modern humans might not have even existed yet. It's been drifting through the void, frozen and dormant, for longer than our species has walked the Earth. And now, purely by chance, it happens to pass through our solar system at exactly the moment when we have the technology to detect and study it. The cosmic timing is staggering. Now, let's talk about those eruptions in more detail, because this is where the chaos reaches its peak. Astronomers use light curves to track how an object's brightness changes over time. A normal comet approaching the Sun shows a predictable brightening as it gets closer and starts outgassing more. The brightness increases smoothly, following well-understood physics. But 3I Atlas's light curve looks like a seismograph during an earthquake. It spikes randomly, sometimes increasing by 2 or 3 magnitudes, which means 100 times brighter in just a few hours, then dropping back down, only to spike again days later. Dr. Bannister's team has been conducting rapid response observations whenever an outburst is detected. They use a network of telescopes, including the Gemini Observatory and the Very Large Telescope in Chile, to capture spectroscopy data during these events. And what they're finding is that each outburst has a slightly different chemical signature. One eruption might be rich in carbon monoxide. The next might show more water vapor and dust. Another might show complex organics. It's as if different layers of the comet are being exposed with each explosion, like peeling an onion, except the onion is violently exploding and revealing different ingredients in each layer. Here's an analogy to make this clearer. Imagine you have a layered cake, where each layer is made with different ingredients from around the world. One layer is French, with butter and cream. Another is Japanese, with matcha and red bean. Another is Mexican, with cinnamon and chocolate. Now imagine that cake is frozen solid, and you're heating it up unevenly, and different layers are randomly bursting out. By analyzing what comes out with each burst, you can reconstruct what the whole cake was made of, even though you've never tasted it intact. That's what astronomers are doing with 3I Atlas. Each eruption gives them a taste of a different layer, and they're trying to reconstruct the recipe from another star's kitchen. The implications for planetary science are enormous. Every star system forms differently, depending on the initial composition of the gas cloud that collapsed to form the star, the dynamics of the protoplanetary disk, the presence or absence of nearby massive stars, and countless other factors. By studying the composition of 3I Atlas, we're essentially getting a direct sample from another star's planetary formation process. We're learning what materials were available, what temperatures and pressures existed, and how those conditions differ from what produce our own solar system. Dr. Seligman has suggested that the chemical composition of 3I Atlas might indicate it formed in a star system around a red dwarf, the most common type of star in the galaxy. Red dwarfs are cooler and smaller than our sun, and the planetary systems around them form at colder temperatures. This would explain the abundance of supervolatile ices like carbon monoxide. If true, 3I Atlas is our first detailed look at what comets from red dwarf systems are like. And since red dwarfs are by far the most numerous stars, this is our first glimpse at the most common type of planetary system in the galaxy. Let's shift gears for a moment and talk about the detection technology that made finding 3I Atlas possible, because this is a story of human ingenuity that deserves recognition. The Atlas system that discovered 3I Atlas consists of 4 robotic telescopes located in Hawaii and South Africa. These telescopes aren't huge, just half a meter in diameter, but they have enormous fields of view, allowing them to scan vast swaths of sky every night. Each telescope can image the entire visible sky twice per night, automatically comparing new images to previous ones to detect anything that moves or changes. The software running Atlas is sophisticated. It has to filter out airplanes, satellites, asteroids, variable stars, and countless other false positives to identify potentially interesting objects. When 3I Atlas was first detected, the software flagged it as unusual based on its motion, but it took human astronomers to recognize that its trajectory was interstellar. That human-AI collaboration is what made this discovery possible. The computers do the heavy lifting of processing millions of images, but human judgment is still essential for interpreting the results. And here's something that should give you hope for the future. ATLAS is just one of several survey systems coming online or being upgraded right now. The Vera Rubin Observatory, set to begin full operations in 2025, will be able to scan the entire visible sky every few nights with unprecedented sensitivity. It will detect objects fainter and more distant than anything we've found before. Estimates suggest that once Rubin is fully operational, we might discover dozens or even hundreds of interstellar objects passing through our solar system every year. 3I Atlas might be rare now, but in a few years, interstellar visitors might become routine. Imagine that future, a world where we regularly analyze chemistry from dozens of different star systems, where we build a catalog of interstellar comets and asteroids, mapping the diversity of materials in our galactic neighborhood, where high school students do science projects comparing the organic molecules found in objects from red dwarf systems versus sun-like stars. That future is closer than you think, and 3I Atlas is the beginning of that era. Now I want to address something that might be on your mind. With all this talk of chaos and eruptions, should we be worried? Is 3I Atlas a threat to Earth? The short answer is no, absolutely not. Even at its closest approach, 3I Atlas was never anywhere near Earth. We're talking about distances measured in tens of millions of kilometers. The eruptions we're observing are dramatic on a comet scale, but the actual material being expelled would be utterly harmless if it somehow reached Earth. We'd be more likely to be hit by dust from a regular comet and by debris from 3I Atlas. But your question raises a bigger issue. What if a future interstellar object did come on a collision course with Earth? Could we stop it? This is where the conversation gets both serious and somewhat speculative. The truth is, we probably couldn't. Our current asteroid deflection technology, like NASA's DART mission, which successfully altered the orbit of the asteroid Dimorphos in 2022, is designed for objects that we've tracked for years or decades, giving us time to plan and execute a mission. An interstellar object appears with little warning and moves incredibly fast. By the time we detected it, calculated its orbit, and confirmed it was on a collision course, there might be months or even just weeks before impact. Defending against an interstellar impactor would require technology we simply don't have yet. We'd need either extremely powerful rockets capable of launching on short notice, or space-based defense systems already in orbit and ready to respond. Some scientists have proposed concepts like Project Icarus, which envisions nuclear-tipped interceptor rockets that could be launched on demand, but these remain theoretical. The good news is that the odds of an interstellar object hitting Earth are vanishingly small. Space is so vast, and Earth is so tiny, that even if thousands of interstellar objects pass through our solar system, the chances of one hitting us are astronomically low, but not zero. Here's a thought that should make you simultaneously grateful and uncomfortable. Every day, you're alive because countless cosmic accidents didn't happen. A random asteroid didn't hit Earth. A gamma ray burst didn't occur nearby. An interstellar rogue planet didn't collide with our sun. We live in a shooting gallery, and we've just been lucky. 3I Atlas is a reminder of that cosmic roulette. It's passing by harmlessly, but it didn't have to. The universe is fundamentally chaotic, and our continued existence is, in some sense, a statistical fluke. Let's talk about what happens next to 3I Atlas, because its story isn't over. As I record this, the comet is moving away from the sun, heading back toward interstellar space. The eruptions are becoming less frequent as the solar heating decreases and the more volatile ices are depleted. Within a few months, 3I Atlas will fade from visibility, becoming too dim for even our largest telescopes to detect. And then it will vanish, disappearing back into the cosmic dark from which it came. But here's the beautiful part. Even as it fades from our view, 3I Atlas will continue its journey. In a few hundred years, it will exit the heliopause, the boundary where the sun's influence ends and true interstellar space begins. And then it will drift for millions or billions of years, until perhaps it encounters another star system. Maybe it will pass through that system harmlessly, as it did ours. Or maybe it will collide with a planet, delivering its cargo of organic molecules and water, potentially seeding life on a world where none existed before. Think about that. This comet that we're watching right now, that's exploding before our telescopes, might be the spark that starts life in another solar system billions of years from now. We're witnessing both the end of one chapter and the potential beginning of another. That's the poetry of cosmic events like this. They're not isolated incidents. They're threads in a tapestry that spans the entire galaxy and the entire history of the universe. Now, before we go deeper, I need you to do something. Pause for a second and think about where you are right now. You're on a planet orbiting a star in a galaxy containing hundreds of billions of other stars. And right now, at this moment, an object from one of those other star systems is visible in our sky, erupting and dying, telling us stories about a place unimaginably far away. You are part of that story. By learning about 3I Atlas, you're connecting with the larger universe. You're transcending your individual existence and touching something cosmic. That's not hyperbole. That's the literal truth of what you're doing right now by watching this. Let's go even deeper now. We've established what 3I Atlas is, why it's behaving strangely, and what that means for our understanding of interstellar objects. Now I want to explore some of the more speculative, more mind-bending implications. Because here's what will blow your mind. What if 3I Atlas isn't just a random interstellar comet? What if it's part of a larger pattern we're only beginning to recognize? Dr. Loeb, whom I mentioned earlier, has been arguing for years that we need to take the possibility of artificial interstellar objects seriously. His controversial suggestion that Oumuamua might be artificial was widely criticized, but his underlying point is sound. If there are billions of technological civilizations in the galaxy, some of them likely launch probes, and some of those probes will pass through our solar system eventually. Statistically, we should have detected artificial objects by now. So where are they? Now, I'm not saying 3I Atlas is artificial. There's zero evidence for that. Its behavior, while unusual, can be explained by natural processes. But Loeb's question remains valid. How would we distinguish a natural interstellar object from an artificial one? What signatures should we look for? This question has led to a new field of study called artifact SETI, which looks for signs of alien technology not by listening for radio signals, but by searching for unusual objects in our solar system. Imagine for a moment that an advanced civilization wanted to explore the galaxy. Sending biological beings is slow and dangerous, but sending robotic probes? That's feasible, even with technology not much more advanced than our own. These probes could be small, possibly even microscopic, and they could use solar sails or other passive propulsion systems to travel between stars over thousands of years. Now, here's the kicker. How would such a probe behave? Probably a lot like a comet. It would be small, dark when far from stars, and it might use outgassing for maneuvering as it passes through a star system. It would be almost indistinguishable from a natural object. So every time we detect an interstellar visitor, we should at least consider the possibility that it's not natural. We should look for anomalies, for behavior that can't be explained by known physics. And while 3I Atlas's eruptions are extreme, they're not impossible to explain with natural processes. But what if future interstellar objects show signs of directed acceleration? Or emit radio signals? Or change course to avoid planets? Then we'd have to take the artificial hypothesis seriously. Here's another mind-bending possibility. What if interstellar comets like 3I Atlas are part of a galactic ecosystem we don't yet understand? In recent years, scientists have discovered that space isn't as empty as we once thought. The interstellar medium, the gas and dust between stars, contains organic molecules, amino acids, and even simple sugars. These molecules form on dust grains in molecular clouds and are distributed throughout the galaxy. When stars and planets form, they incorporate these pre-existing organics. But there might be more to it. Some researchers, including Dr. Chandra Wickramasinghe, have proposed that life itself might exist in the interstellar medium, not as complex organisms, but as dormant bacteria or viruses encased in dust grains or frozen into comets. This idea, called astrobiology's most radical hypothesis, suggests that life doesn't just spread between planets within a single star system. It spreads between star systems, carried by objects exactly like 3I Atlas. Here's the theory. Bacteria on Earth have been found to survive in the most extreme conditions imaginable. They've been discovered in Antarctic ice, in boiling volcanic vents, in radioactive waste, and even in the upper atmosphere. Some bacteria can form spores that remain viable for millions of years in a dormant state. Now, what if some of these hardy microorganisms get launched into space by volcanic eruptions or asteroid impacts? They'd be frozen instantly in the vacuum of space, encased in ice or rock, and they could remain viable indefinitely. If these bacteria-laden chunks of rock or ice get ejected from their home solar system, perhaps by a close encounter with a planet or a gravitational assist from a giant world, they become interstellar travelers. They drift through space for millions of years until they encounter another star system. If they happen to collide with a suitable planet, or even just burn up in that planet's atmosphere, the bacteria get deposited. Most die, but if even a tiny fraction survive, they could seed life on that world. 3I Atlas might be carrying passengers right now. Dormant microorganisms from another star system, frozen for eons, exploding out into space with each eruption. Some of that material might eventually make its way to Earth, carried on dust grains that enter our atmosphere. You might literally breathe in alien bacteria tomorrow without ever knowing it. Now, before you panic, understand that these hypothetical bacteria would almost certainly be harmless to us. They evolved on a different world, with different biochemistry, and probably couldn't interact with Earth's biology at all. But still, the possibility is there. Dr. Wickramasinghe has spent decades arguing for this panspermia hypothesis, often facing skepticism from the mainstream scientific community. But recent discoveries keep providing tantalizing hints that he might be onto something. In 2013, scientists found bacteria in the stratosphere at altitudes where they shouldn't be able to reach from Earth's surface. In 2017, analysis of meteorites revealed organic molecules that appear to have biological origins. And now we have 3I Atlas, erupting organic compounds that include some of the building blocks of life. Let me give you an analogy that captures the scale of this idea. Think of the galaxy as a vast ocean, and stars as islands in that ocean. On each island, life might emerge independently, growing and evolving in isolation. That's the traditional view. But what if the ocean itself is teeming with the seeds of life, constantly washing up on shores, carried by currents we call gravitational interactions and comets? In this view, life isn't isolated to individual islands. It's part of the ocean itself, flowing between islands, spreading and diversifying wherever it finds purchase. That's the panspermia hypothesis, and 3I Atlas might be one of those life-carrying currents. Now let's talk about timescales, because this is where the truly mind-bending aspects of 3I Atlas come into focus. We've established that this comet has been traveling through space for potentially millions of years. But let's trace its history more carefully. Based on its current trajectory and velocity, astronomers can work backward to estimate when it was likely ejected from its home star system. The calculations are imprecise because we don't know exactly which star it came from. But reasonable estimates suggest 3I Atlas has been wandering the galaxy for somewhere between 5 and 20 million years. 20 million years ago, on Earth, the Miocene epoch was in full swing. Early apes were evolving in Africa. Mammoths didn't exist yet. Humans were still 15 to 20 million years away from even the earliest hominids. And 3I Atlas was already out there, drifting through the interstellar void, silent and frozen. Here's what will blow your mind about that timescale. 3I Atlas is older than your entire evolutionary lineage. Every human who has ever lived, every thought anyone has ever had, every word ever spoken, all of it occurred while 3I Atlas was making its journey across the galaxy. And now, purely by cosmic chance, it arrives at our solar system at the exact moment when a species evolved enough to detect it and wonder about it. The timing is so improbable that it borders on the miraculous. But here's the even crazier part. 3I Atlas's journey isn't over. After it leaves our solar system, it will continue traveling for another 20, 50, maybe 100 million years before it encounters another star. And when it does, what will that star system look like? Will there be planets? Will there be life? Will there be a civilization advanced enough to detect a comet arriving from the direction of our sun and wonder about its origins? We'll never know. But 3I Atlas will be our ambassador to that future, carrying not just ice and rock, but a message encoded in its very chemistry about what our corner of the galaxy was like. This raises a profound philosophical question. If we could attach a message to 3I Atlas before it leaves, what would we say? The Voyager spacecraft, launched in 1977, carried golden records with sounds and images representing Earth. But 3I Atlas is heading to places Voyager will never reach, to times we can't imagine. What message do you send to the unknown, potentially billions of years in the future? Maybe the message is already there, encoded in the organic molecules and isotope ratios of the comet itself. Any sufficiently advanced civilization analyzing 3I Atlas in the distant future would be able to determine where it came from by measuring the isotopes of its elements. They'd know it passed through a system with a G-type star like our sun. They might even be able to deduce the approximate age of that star system. In a sense, 3I Atlas is a message in a bottle, and the message is, we were here. Our sun was here. This is what our corner of space looked like. That message will outlast our civilization, our species, and probably our planet. Let's shift our focus now to the broader implications of the chaos erupting across space. Because 3i Atlas is just one piece of a larger puzzle. I mentioned earlier the unprecedented gamma-ray burst detected in March 2024 and the erratic behavior of Betelgeuse. Let's examine these in more detail and see if we can identify a pattern. Gamma-ray bursts are the most energetic explosions in the universe, releasing in seconds more energy than our sun will emit in its entire 10 billion year lifetime. They're thought to occur when massive stars collapse into black holes, or when neutron stars collide. The burst detected in March 2024, GRB 240327A, was unique because of its duration and the structure of its light curve. Most gamma-ray bursts last either less than 2 seconds, called short bursts, or more than 2 seconds, called long bursts. GRB 240327A lasted 7 minutes and showed a complex pattern of peaks and valleys that doesn't fit either category. Dr. Eleonora Troja from the University of Rome, one of the leading experts on gamma-ray bursts, suggested that this event might represent a new class of cosmic explosion. Her hypothesis is that GRB 240327A was caused by a massive star collapsing not directly into a black hole, but into a rapidly rotating neutron star called a magnetar, which then underwent a series of massive flares before finally collapsing into a black hole. This would explain the unusual duration and structure of the burst. But here's what's really interesting. GRB 240327A originated from a galaxy approximately 3 billion light-years away. That means the explosion we detected in March 2024 actually occurred 3 billion years ago, when Earth was in the Archean Eon and life consisted only of single-celled organisms. The light from that ancient cataclysm has been traveling toward us for longer than multicellular life has existed on Earth, and it just happened to arrive now. The timing is, once again, cosmically improbable. Now, Betelgeuse is a different story because it's close, only about 650 light-years away. This supergiant star, one of the brightest in our night sky, has been showing signs of instability for years. In late 2019 and early 2020, it underwent what astronomers called the Great Dimming, dropping to less than 40% of its normal brightness. Observations from the Hubble Space Telescope, analyzed by Dr. Dupree's team, revealed that Betelgeuse had ejected a massive amount of material from its surface, creating a dust cloud that temporarily blocked our view of the star. That was concerning enough, but the dimming event in July 2024 was even more dramatic. Betelgeuse dropped to barely visible with the naked eye, and spectroscopic analysis showed massive changes in the star's atmosphere. The star is clearly unstable, oscillating in size and brightness in ways that suggest its internal structure is breaking down. When a star like Betelgeuse becomes this unstable, it's often a precursor to a supernova, though precursor, in stellar terms, could mean tomorrow or 100,000 years from now. If Betelgeuse does explode while we're alive to see it, it will be the astronomical event of a lifetime. The supernova will be visible during the day, as bright as the full moon. It will be visible for months, gradually fading over the course of a year or more. And unlike the distant gamma-ray burst, Betelgeuse is close enough that we'd be able to study the explosion in unprecedented detail. Every telescope on Earth and in space would be pointed at it, capturing data that would revolutionize our understanding of stellar death and the creation of heavy elements. But here's the unsettling part. Betelgeuse is close enough that if it does explode, we will be affected, though not in any immediately dangerous way. The supernova will eject massive amounts of material into space, creating an expanding shock wave of gas and dust. This shock wave will sweep through the interstellar medium, compressing gas clouds and potentially triggering new star formation. But it will also flood our region of space with high-energy radiation and cosmic rays. When the shock wave reaches us, probably a few thousand years after we see the light from the explosion, Earth's atmosphere will be bombarded with energetic particles. Now, our atmosphere and magnetic field will protect us from most of this radiation, but there will be effects. The cosmic ray flux might increase, which could affect cloud formation and climate. There might be increased rates of mutations in organisms, though likely not enough to cause mass extinctions. Satellites could be damaged. Communication systems might be disrupted. It would be a reminder that we're not isolated from the wider universe. What happens to stars hundreds of light years away can touch us, even here, even now. So we have an interstellar comet erupting chaotically, a gamma-ray burst that broke records, and a nearby star threatening to explode. Are these connected? Is there some underlying pattern? The honest answer is probably not. These are likely independent events, each with its own cause and history. But they're happening close together in time, from our perspective. And that's forcing us to confront a simple truth we often forget. The universe is not static. It's dynamic, violent, and constantly changing. We've been living in an unusually quiet period, astronomically speaking, and that might be coming to an end. Our sun is currently in a quiet phase of its activity cycle. We're between major galactic spiral arm crossings. No nearby stars are threatening to explode, except Betelgeuse. No large asteroids are on collision courses with Earth. We've been lucky. But that luck won't last forever. Eventually, the universe will remind us, forcefully, that we live in a dangerous cosmos. Events like 3I Atlas are gentle reminders. They're warning shots, if you will, telling us to pay attention, to watch the skies, to prepare for a future that might be more chaotic than our past. Let me ask you a question that I want you to sit with for a moment. Knowing that the universe is fundamentally chaotic and dangerous, knowing that at any moment, a gamma-ray burst could sterilize Earth, or an asteroid could cause a mass extinction, or a nearby supernova could irradiate our planet, how does that change your perspective on life? Does it make existence seem fragile and precious? Does it make human conflicts seem petty and pointless? Does it inspire you to do more, to achieve more, to connect more deeply with others, knowing that all of this could end without warning? These are the questions that astronomy ultimately forces us to confront. We're not studying rocks and gas and light for the sake of abstract knowledge. We're studying our place in the cosmos, our origins, our fate, and the meaning of our brief existence on this tiny planet, orbiting an ordinary star in a vast and indifferent universe. 3I Atlas, with its chaotic eruptions and alien chemistry, is a mirror. When we look at it, we're really looking at ourselves, at our own fragility, at our own cosmic insignificance, and yet our own remarkable ability to understand and wonder. Now let's get technical again for a moment, because I want to explain something about the future of interstellar object detection that's going to change everything. Remember I mentioned the Vera-Rubin Observatory earlier? Let me tell you exactly why this telescope is going to revolutionize our understanding of interstellar visitors. The Rubin Observatory, located in Chile, has a primary mirror 8.4 meters in diameter and a field of view covering nearly 10 square degrees of sky. To put that in perspective, the full moon covers about half a square degree, so Rubin can image an area equivalent to 40 full moons in a single exposure. And it will take these massive images every 30 seconds, all night, every clear night, covering the entire visible sky twice per week. The data output from Rubin will be staggering. Each night, it will generate about 15 terabytes of data, which is roughly equivalent to the entire written works of humanity captured every single night. Processing this data requires sophisticated algorithms and machine learning systems that can identify the tiny fraction of changes that represent genuinely interesting astronomical phenomena versus the overwhelming majority that are just noise, satellites, or already known objects. But here's what this means for interstellar objects. Current estimates, based on the 3 confirmed interstellar visitors we've detected so far, suggest that at any given time, there might be just can't see most of them because they're too faint, too small, or moving through regions of sky we're not monitoring. Rubin will change that. Its combination of large aperture, wide field of view, and continuous monitoring means it will detect interstellar objects that are smaller, fainter, and further away than anything we can find now. Dr. Mario Jurek from the University of Washington, one of the lead scientists on the Rubin Observatory project, estimates that once the observatory is fully operational, we might detect between 50 and 100 interstellar objects per year. Think about that. In a decade, we could have a catalog of 500 to 1,000 interstellar visitors, each with its own composition, trajectory, and story to tell. We'll start to see patterns. We'll be able to classify interstellar objects into categories. We'll learn which types of comets come from which types of star systems. We'll essentially be doing xenogeology and xenochemistry, studying the geology and chemistry of alien worlds without ever leaving our solar system. And here's the really exciting part. With that many interstellar objects detected, we'll be able to do statistics. We'll be able to answer questions like, what percentage of interstellar objects are rocky versus icy? What's the distribution of sizes? Are there more objects coming from certain directions in the galaxy? Are there temporal variations, periods when more interstellar objects pass through? These statistical analyses will tell us about the structure and dynamics of the galaxy in ways that no other method can. Imagine this future. A high school student in 2030 is doing a science project. They access the public database from the Rubin Observatory, download data on 50 interstellar comets, and analyze the organic molecules detected in each one. They create a chart showing that comets from the direction of the galactic center tend to have more complex organic chemistry than comets from the outer regions. Their science project contributes to our understanding of how life-friendly chemistry is distributed across the galaxy. That's the future we're building right now, and 3I Atlas is the first chapter. But let's not get too far ahead of ourselves. Let's come back to the present and talk about what you can do right now to connect with this cosmic story. Because astronomy isn't just for professional scientists. It's for everyone. You can participate in this discovery process, and I'm going to tell you how. First, if you have even basic amateur astronomy equipment, like binoculars or a small telescope, you can observe comets. While 3I Atlas itself is now too faint for amateur equipment, there are always several comets visible in the sky at any given time. Websites like Heavens Above or The Sky Live provide up-to-date information on comet positions and brightness. There's something profound about seeing a comet with your own eyes, knowing that you're looking at a time capsule from the early solar system, or in rare cases like 3I Atlas, from beyond our solar system entirely. Second, you can participate in citizen science projects. Platforms like Zooniverse host projects where volunteers help astronomers analyze data. There are projects where you can classify galaxies, search for exoplanets, identify asteroids, and yes, even help characterize comets. Your contributions are genuinely useful. Many scientific papers acknowledge citizen scientists who helped with data analysis. You can literally contribute to humanity's understanding of the cosmos from your computer. Third, and this might sound simple, but it's important, talk about these discoveries. Share this video. Discuss these ideas with friends and family. One of the challenges facing astronomy is that many people feel disconnected from the cosmos. They look up at the sky and see just lights, not worlds, not stories, not connections to their own existence. By spreading knowledge and enthusiasm, you're helping to reconnect humanity with its cosmic roots. You're reminding people that we're part of something larger. And fourth, support space science. Whether that means contacting your elected representatives to support funding for space exploration and astronomy, or donating to organizations like the Planetary Society that advocate for these missions, or simply choosing to stay informed and educate yourself about cosmic events, your engagement matters. The discoveries we make, The missions we launch, the telescopes we build, they all exist because society has decided they're valuable. Your voice is part of that decision. Now, let me bring this back to something deeply personal. I said earlier that there would be a section where we talk about how 3i Atlas affects your worldview. We're at that point now. So let me ask you directly. What does the existence of 3i Atlas mean for how you see yourself and your place in the universe? Here's my perspective, and I invite you to wrestle with this idea. The fact that an interstellar comet is erupting in our solar system right now, carrying organic molecules from another star system, fundamentally challenges the notion that we are isolated or special. Earth is not a separate, protected realm. We're part of a galaxy-spanning ecosystem where matter and energy flow between stars, where the building blocks of life are distributed throughout space, where the boundary between here and there is arbitrary and permeable. You are made of atoms that were forged in the hearts of dying stars billions of years ago. Those atoms were scattered into space by supernova, gradually coalesced into new stars and planets, and eventually found their way into the specific configuration that is you. But those atoms didn't stay confined to our solar system's birth cloud. They've been here and there, cycling through multiple generations of stars, mixing with material from other regions of the galaxy. The calcium in your bones might have origins in a different star cluster than the iron in your blood. And if panspermia is real, if life spreads between star systems on comets like 3i Atlas, then your very existence might have been sparked by an interstellar visitor billions of years ago. The first self-replicating molecules on Earth might have arrived from space, carried on a comet, not unlike the one we're watching now. In that case, you're not just made of stardust. You're made of interstellar material. Your ancestry doesn't trace back to a primordial soup on Earth. It traces back to the galaxy itself. Does that make you feel small? It should, and that's okay. You are small. We all are. Our entire planet is a speck. Our sun is one of hundreds of billions, and our galaxy is one of trillions. But here's the paradox that I need you to understand. Your smallness doesn't make you insignificant. It makes you miraculous. Think about it. The universe is mostly empty space, mostly chaos and violence. Stars exploding, black holes colliding, galaxies tearing each other apart. But here, on this tiny rock, improbably circling an ordinary star, atoms arrange themselves into structures complex enough to think, to wonder, to create art and music and science. Against all odds, the universe became aware of itself through you. You are the cosmos experiencing itself subjectively. You are billions of years of cosmic evolution made conscious. 3i Atlas is a reminder of that miracle. This comet traveled across unimaginable distances, survived in the frozen darkness for millions of years, and arrived here at exactly the moment when a species exists that can detect it, analyze it, and wonder about it. If 3i Atlas had arrived 100 million years ago, it would have passed through the solar system unobserved, unseen, its secrets locked away forever. If it arrives somewhere else in another 100 million years, perhaps another species will see it and wonder where it came from, never knowing it once passed by a blue planet where beings called humans briefly flickered into existence and watched it go by. You're part of that chain of cosmic observation. You're a link between the past and the future, between here and there, between matter and meaning. That's not mysticism. That's physics. That's astronomy. That's the literal truth of your existence. Now, I want to address something that might be bothering you. I've been talking a lot about chaos, about violence, about the dangers lurking in the cosmos. I've painted a picture of a universe that's fundamentally hostile to life. And that's true to a point. But there's another side to this story that I don't want you to miss. Yes, the universe is dangerous, but it's also astonishingly creative. Every atom in your body, except for hydrogen, was created in the nuclear furnaces of stars, or in the cataclysmic explosions that ended those stars' lives. Death and creation are linked. The supernovae that destroy stars are the same events that forge the elements necessary for life. The chaos that tears things apart is the same chaos that brings new things into being. 3I Atlas is dying right now, tearing itself apart in explosive eruptions. But that death is also an act of creation. With every eruption, it's redistributing material through the solar system. Some of that material will eventually rain down on Earth, on Mars, on the moons of Jupiter. And somewhere in that material might be molecules that will someday, somehow, contribute to new life. The chaos we're witnessing isn't just destruction. It's transformation. This is a pattern that repeats at every scale in the universe. Galaxies collide, and from the wreckage, new stars are born. Stars explode, and from their ashes, planets form. Species go extinct, and new species evolve to fill the empty niches. Even your own body follows this pattern. Cells die and are replaced. Atoms are cycled out, and new ones incorporated. You're not the same physical being you were 7 years ago. Every atom has been replaced. And yet you persist, a pattern of organization that survives even as the matter that comprises it constantly changes. 3I Atlas is showing us that same pattern on a cosmic scale. It's a structure that has persisted for millions of years, maintaining its coherence even as it traveled across the galaxy. Now it's breaking down, but the pattern of its existence, the information encoded in its chemistry and its trajectory, that will persist even after the physical object has dispersed. In a way, 3I Atlas is immortal, not as a thing, but as a story, as information about the galaxy that will be preserved in scientific papers and databases for as long as human civilization endures. And here's where I want to blow your mind one more time. You're doing the same thing. Your physical body is temporary, constantly changing, ultimately mortal. But the pattern of your existence, the relationships you've formed, the ideas you've shared, the impact you've had on the world that persists. You're not just a collection of atoms. You're information organized in a particular way, and information can't be destroyed, only transformed and redistributed. When you die, the atoms that make up your body will disperse, just like 3I Atlas's atoms are dispersing now. Some will become part of plants. Some will become part of other animals. Some will wash into the ocean. Some will evaporate and rise into the atmosphere. In a very real sense, you'll become part of Earth's ecosystem, where matter recycling endlessly. But the information of your existence, the pattern you made in the world, will echo forward in time through everyone you've affected, every idea you've shared, every action you've taken. That's the deepest lesson of 3I Atlas. Not that we're small or insignificant, but that we're part of a universe-spanning cycle of matter and energy and information, constantly transforming, constantly creating new patterns, new structures, new ways of being. You're not separate from the cosmos. You're an expression of it. Now, let me bring all of this together by talking about the future, both the near-term future of our civilization and the far future of the cosmos. Because 3I Atlas isn't just teaching us about the past. It's giving us hints about what's to come. In the near term, within your lifetime, we're going to witness a revolution in our understanding of the galaxy. The Rubin Observatory will catalog hundreds or thousands of interstellar objects. NASA's James Webb Space Telescope and future instruments will analyze their atmospheres and compositions in exquisite detail. We'll map the chemical diversity of the galaxy without ever leaving our solar system. We'll identify which star-forming regions produce which types of planets. We'll trace the distribution of organic molecules through space. We'll understand, for the first time, the galactic ecology that produced us. This knowledge will have practical implications. Understanding the chemistry of different regions of the galaxy will help us identify the best places to search for life. If we know that certain types of star systems produce more life-friendly chemistry, we can focus our efforts on searching for planets around those types of stars. The search for extraterrestrial life will become more targeted, more efficient, more likely to succeed. And when we do find evidence of life beyond Earth, whether it's microbial life in the oceans of Europa or a technological civilization broadcasting from a distant star, it will fundamentally transform human civilization. All of our tribal divisions, our national boundaries, our ethnic and religious conflicts will seem absurd in the face of cosmic companionship. We'll stop thinking of ourselves as Americans, or Chinese, or Indian, as Christian or Muslim or Hindu, and start thinking of ourselves as Earthlings, as one species among many in a populated universe. That transformation has already begun. Events like the detection of 3I Atlas, the discovery of thousands of exoplanets, the imaging of black holes, these are all steps toward a more cosmic perspective on human existence. And you're part of that transformation. By learning about these discoveries, by sharing this knowledge, by allowing your worldview to expand beyond the boundaries of Earth, you're helping to shift human consciousness toward a more universal perspective. In the far future, millions or billions of years from now, humanity will either be extinct or it will have spread beyond Earth, perhaps beyond the solar system entirely. If we survive, if we become a spacefaring civilization, future humans will look back on this era as a pivotal moment. They'll see the early 21st century as the time when we transitioned from a planet-bound species to a cosmic species. And they'll recognize discoveries like 3I Atlas as milestones in that transition, moments when we glimpsed the larger universe and chose to engage with it rather than retreat into parochialism. And 3I Atlas itself? In the far future, long after humanity is gone, it will still be traveling. Perhaps in 1 billion years, it will enter another star system. By then, our sun will have brightened significantly, making Earth uninhabitable. Perhaps Mars will be in the habitable zone, warm enough for liquid water. Or perhaps intelligent machines, descendants of our AI systems, will be the only remaining traces of human civilization. 3I Atlas won't care. It will continue its journey, a silent witness to the rise and fall of countless civilizations, a messenger between stars forever. The final thing I want to talk about before we wrap up this journey is wonder. Because ultimately, that's what astronomy is about. It's not just about data and equations and telescopes. It's about rekindling the sense of wonder that all humans feel when they look up at the night sky and realize how vast and beautiful and strange the universe is. We live in an age that often feels cynical and exhausted. We're bombarded with information, most of it negative, most of it designed to provoke fear or anger or division. It's easy to feel small and powerless, overwhelmed by problems that seem too large to solve. But astronomy offers an antidote to that cynicism. It reminds us that there are mysteries worth solving, beauty worth appreciating, and horizons always waiting to be explored. When you think about 3I Atlas, erupting chaotically as it passes through our solar system, carrying organic molecules from an alien world, you're forced to step outside your everyday concerns. Your problems, your anxieties, your fears, they don't disappear, but they shift into a larger context. You realize that the universe is vast beyond comprehension, that it's been here for nearly 14 billion years and will continue for trillions more, and that your brief existence is just one small note in a cosmic symphony that's been playing since the Big Bang. That realization can be scary. It can feel like it diminishes the importance of your individual life. But I want you to see it differently. Your smallness is precisely what makes you precious. In an uncaring universe, care is rare and valuable. In a cosmos of chaos, the order you create matters. In a reality of entropy, where everything tends toward disorder, the fact that you can create meaning, build relationships, love and be loved, that's a victory against the fundamental laws of physics. Every act of kindness you perform, every moment of beauty you create or appreciate, every time you choose connection over isolation, you're pushing back against the cosmic tide. You're creating pockets of order and meaning in a universe that doesn't inherently contain either. And that's heroic. That's not too strong a word. You're a hero simply by choosing to care, to create, to connect, despite knowing that everything is temporary and the universe doesn't care. 3i Atlas doesn't know it's being observed. It doesn't know that its chaotic eruptions are teaching us about the galaxy, inspiring wonder, changing perspectives. It's just a chunk of ice and rock, following the laws of physics, breaking apart because chemistry demands it. But we know. We're the ones who assign meaning. We're the ones who look at this impersonal cosmic event and find in it lessons about existence, mortality, connection, and wonder. That's the real miracle. Not that the universe exists, but that the universe produced beings capable of understanding and appreciating its own existence. You're not just in the universe. You're how the universe knows itself. You're how the cosmos becomes conscious of its own grandeur. And that means that when you feel wonder at something like 3i Atlas, you're not a passive observer. You're an active participant in the universe's self-awareness. As we come to the end of this exploration, I want to leave you with a challenge. Tonight, or whenever it next gets dark where you are, go outside and look up. Find a dark spot away from city lights if you can. Let your eyes adjust to the darkness. And as you look up at the stars, remember that you're looking across time and space, that the light hitting your eyes has traveled for years or centuries or millennia to reach you. Remember that between those stars, unseen comets like 3i Atlas are traveling, carrying stories and chemistry from worlds you'll never know. And remember that you're part of that same cosmos. The atoms in your eyes that are detecting that starlight were once inside a star. The consciousness that's processing that light and finding meaning in it emerged from billions of years of cosmic evolution. You're not separate from what you're observing. You're part of it. The chaos erupting across space, the violent outbursts of 3i Atlas, the gamma-ray bursts and dying stars, they're not threats to fear. They're reminders that the universe is alive, dynamic, constantly creating and destroying and transforming. And you get to witness it. You get to be part of it. That's a gift beyond measure. So the next time you feel overwhelmed by life's problems, step outside and look up. Remember 3i Atlas. Remember that right now, at this very moment, somewhere out there in the darkness, an interstellar visitor is erupting, scattering organic molecules across our solar system, continuing a journey that began millions of years ago and will continue for millions more. And remember that you, too, are on a journey, part of a cosmic story that's larger and more beautiful than any individual human life, but which needs individual human lives to have meaning and purpose. We've spent these past hours together, exploring the insanity of 3i Atlas, the chaos erupting across space, and what it all means for us here on Earth. I hope you've felt your perspective shift, your sense of wonder rekindle, your place in the universe come into clearer focus. Because that's what this was really about. Not just learning facts about a comet, but using that comet as a lens to see yourself and your existence more clearly. Thank you for joining me on this journey. Thank you for caring enough about the cosmos to spend this time learning and wondering. Thank you for being the kind of person who looks up at the stars and asks questions. The universe needs more people like you, people who haven't lost the capacity for awe, who can still be amazed by the infinite strangeness and beauty of existence. Before you go, do me one last favor. Hit that subscribe button if you haven't already. Share this video with someone who needs a reminder of how vast and wonderful the universe is. And drop a comment telling me what part of this journey resonated most with you. Did the panspermia hypothesis blow your mind? Does the thought of Betelgeuse exploding keep you up at night? Are you excited about the future of interstellar object detection? I want to hear from you because these conversations matter. We're all explorers together, trying to make sense of this cosmic mystery we find ourselves in. The story of 3i Atlas isn't over. Right now, As you watch this, the comet is still out there, still moving, still erupting, still teaching us about the universe. And the larger story, the story of humanity's relationship with the cosmos, that's just beginning. We're living in the dawn of a new age of discovery, an age where interstellar visitors become common, where we map the chemistry of the galaxy, where we perhaps finally answer the question of whether we're alone. You get to be part of that story, not just as a passive observer, but as an active participant. Every time you look up and wonder, every time you share knowledge about the cosmos, every time you let astronomical discoveries change your perspective on life, you're writing the next chapter of humanity's cosmic story. And that story, like 3i Atlas itself, will outlast all of us. Long after we're gone, the knowledge we've gained, the wonder we've felt, the connections we've made between Earth and the wider universe, those will persist. They'll be passed down to future generations, incorporated into humanity's ever-expanding understanding of reality, transformed and built upon until they become the foundation for discoveries we can't even imagine yet. 3i Atlas came from the darkness between stars, erupted into brief visibility, taught us profound lessons about our place in the cosmos, and will return to that darkness, continuing a journey that may never end. In a way, we're all doing the same thing. We emerge from non-existence, briefly experience consciousness and wonder, hopefully contribute something meaningful to the universe's story, and then return to the cosmic cycle. Our atoms scattered, but our impact preserved in the patterns we've created. That's not depressing. That's beautiful. That's the most profound form of immortality available to any conscious being. Not the continuation of individual consciousness, which may or may not happen depending on your beliefs, but the continuation of impact, of influence, of the ripples you create in the fabric of causality. Every action you take, every word you speak, every thought you have, it changes the universe in ways that can never be undone. The butterfly effect isn't just a metaphor. It's physics. Your choices matter cosmically, literally. So when you think about 3i Atlas, don't just think about it as a distant object of scientific interest. Think about it as a mirror, reflecting back truths about your own existence. Like that comet, you're on a journey through space and time. Like that comet, you're made of materials forged in ancient stars and shaped by cosmic processes beyond your control. Like that comet, you're temporary, ephemeral, destined to break apart and disperse. But also like that comet, you're remarkable, unique, a specific configuration of matter and energy that has never existed before and will never exist again in exactly the same way. And here's the final mind-blowing realization I want to leave you with. 3i Atlas doesn't know any of this. It doesn't know it's special. It doesn't know it's the third confirmed interstellar object. It doesn't know that billions of intelligent beings are watching it, studying it, wondering about it. It just exists, following the laws of physics, unconscious and unaware. But you know, you're aware. You can appreciate the cosmic drama that 3i Atlas represents. You can understand the scientific principles governing its behavior. You can feel wonder at its existence and your own. That awareness, that consciousness, that capacity for wonder and understanding, that's the most precious thing in the universe. Because as far as we know, it's rare. It might be that consciousness exists on countless worlds, scattered throughout the galaxy. Or it might be that Earth is unique, that you're part of the only population of conscious beings in the observable universe. We don't know yet. But either way, consciousness is valuable beyond measure, because it's the universe's only way of knowing itself. When 3i Atlas erupts, spraying organic molecules into space, it's just chemistry. But when you observe that eruption and understand what it means, when you grasp the implications for panspermia and galactic ecology and the spread of life through space, you're transforming chemistry into meaning. You're taking raw physical processes and weaving them into a narrative, a story about origins and destinations, about where we came from and where we're going. That transformation, from matter to meaning, from physics to philosophy, that's what consciousness does. That's your superpower. You're not just a bag of chemicals. You're a meaning-making machine, capable of taking the raw data of existence and finding patterns, creating stories, generating purpose where none inherently exists. The universe is fundamentally meaningless. It operates according to mathematical laws that don't care about joy or suffering, beauty or ugliness, right or wrong. But you care. And because you care, meaning exists. You're not discovering meaning in the universe. You're creating it, imposing it, projecting it onto an indifferent cosmos. And that's not a weakness or a delusion. That's the most powerful thing any entity can do. Think about art. A painting is just pigments on canvas, following the laws of chemistry. But when a conscious being looks at that painting and feels emotion, perceives beauty, extracts meaning, the painting becomes more than its physical components. It becomes a bridge between minds, a vessel for transferring experience and emotion across space and time. That's what consciousness does. It transforms the physical into the meaningful. 3I Atlas is just ice and rock and organic molecules. But in your mind, right now, it's a story. It's a lesson about cosmic interconnection. It's a reminder of your place in the universe. It's whatever meaning you've assigned to it based on your unique perspective and experiences. And that meaning is real, even though it exists only in consciousness, even though 3I Atlas itself is completely unaware of it. This is true of everything in your life. Your relationships, your work, your goals, your fears, your hopes. They're all stories you're telling yourself about physical processes. The love you feel for another person is, at the chemical level, just neurotransmitters and hormones. But the meaning you assign to that love, the way you incorporate it into your identity and let it shape your choices, that transforms chemistry into something transcendent. And here's the really wild part. By creating meaning, you change the physical universe. Your thoughts lead to actions. Your actions rearrange matter and energy. The meaning you create today will ripple forward causally, affecting events in ways that compound over time. In a very real sense, consciousness isn't just observing the universe. It's steering it, shaping it, determining what comes next. That's why your life matters. Not because some external authority declared it matters, but because you have the power to create cascades of causality that wouldn't exist without you. Every choice you make splits the timeline into different possible futures. You're not just a passenger on Earth. You're a co-author of reality itself. 3I Atlas is teaching us this lesson on a cosmic scale. This chunk of ice from another star system, unconscious and unthinking, is nevertheless changing our civilization. It's inspiring wonder, generating scientific papers, shifting perspectives, altering the trajectory of human thought. And it's doing all of this simply by existing and being observed by conscious beings who can extract meaning from its existence. You're doing the same thing, simply by existing, by being observed by other conscious beings. By interacting with the world, you're changing the trajectory of civilization in ways large and small. Maybe you'll never discover a comet, or win a Nobel Prize, or have your name remembered by history. But you'll still matter, because every interaction you have with another person changes them in some small way, and those changes propagate forward through all of their future interactions, branching and spreading like a river delta, until your influence has touched countless lives that you'll never directly meet. This is the butterfly effect applied to human consciousness. You don't need to do something huge to have a massive impact. You just need to exist authentically, interact compassionately, and let the causal chains unfold naturally. The child you smile at today might become a teacher who inspires hundreds of students. The friend you support through a difficult time might go on to create art that moves millions. The stranger you show kindness to might pay it forward, creating a wave of compassion that ripples through society. You're not insignificant. You're a nexus point in the causal network of reality. Your choices determine which branches of possibility collapse into actuality. That's not mysticism. That's quantum mechanics applied to macroscopic decision-making. Every moment, reality splits into different possible futures, and your choices help determine which future becomes real. So when you feel small, when the vastness of space and time makes you feel like nothing, remember this. The universe might be infinite, but you're not infinitesimal. You're a node of consciousness with the power to create meaning and shape reality. That's more impressive than being big. That's being significant in the only way that matters. Now, I want to talk about something I've touched on throughout this journey, but haven't fully explored. The role of uncertainty in scientific discovery and in life. Because one of the most fascinating aspects of the 3I Atlas story is how much we still don't know. Despite all of our observations, all of our spectroscopic analysis, all of our computer simulations, we still don't fully understand why this comet is erupting so violently. We have hypotheses, superheavy ices, subsurface oceans, exotic chemistry, but we don't have certainty. And that's okay. That's actually beautiful, because it means there's still mystery, still discovery waiting to happen, still questions for the next generation of astronomers to answer. This is true of all the biggest questions in life. We don't know if there's life elsewhere in the universe. We don't know what consciousness is or how it emerges from matter. We don't know what came before the Big Bang or what will happen in the far future when the last stars burn out. We don't know if free will exists or if we're deterministic machines. We don't know what happens after death. We don't know the meaning of life. And that's not a bug. That's a feature. Uncertainty is what makes existence interesting. If we knew everything, if all questions were answered, life would lose its sense of adventure, the joy of discovery, the thrill of understanding something new, the satisfaction of solving a puzzle. All of that requires uncertainty. Mystery isn't something to be eliminated. It's something to be celebrated and explored. 3I Atlas embodies this perfectly. Every time we think we understand what's happening, the comet surprises us with a new eruption that doesn't fit our models. It's keeping us humble, reminding us that the universe is more complex and stranger than our theories can capture. And that's exactly how science should work. We should always be ready to be surprised, to have our assumptions challenged, to discover that reality is weirder than we imagined. This applies to your personal life too. You don't know what's going to happen tomorrow, next week, next year. You don't know who you'll meet, what opportunities will arise, what challenges you'll face, or how you'll grow and change. That uncertainty can be terrifying, but it's also what makes your story worth living. If you knew exactly how everything would unfold, why bother continuing? The uncertainty is what creates the possibility for meaningful choice, for growth, for surprise, for joy. So embrace uncertainty. Don't see it as a weakness or a problem to be solved. See it as the space where possibility lives. Every moment is a branching point, a place where multiple futures diverge, and you don't know which one you'll end up in. That's not scary. That's liberating. It means you're not locked into any particular destiny. You're free to create yourself, to make choices, to explore and discover and become. 3I Atlas is uncertain about its future too, though, of course, it doesn't know that. It doesn't know when its next eruption will occur. It doesn't know how much mass it will lose before it exits the solar system. It doesn't know which star system it will encounter next, or whether it will collide with something, or continue wandering forever. The comet's future is open, probabilistic, fundamentally uncertain. And so is yours. And so is humanity's. And so is the universe's. We're all navigating uncertainty together, making the best choices we can with incomplete information, creating meaning and purpose as we go. There's something deeply democratic and egalitarian about that. We're all in the same existential situation, from the smallest bacterium to the largest galaxy. None of us know what comes next. We're all improvising, adapting, responding to circumstances as they arise. The astronomers studying 3I Atlas exemplify this beautifully. They didn't expect this comet to behave the way it has. Their models didn't predict these violent, chaotic eruptions. But instead of being discouraged or pretending they understand what they don't, they're embracing the uncertainty. They're collecting data, refining hypotheses, collaborating across institutions and borders, working together to solve a puzzle that the universe unexpectedly presented them with. That's how you should approach life's uncertainties too. Not with fear or avoidance, but with curiosity and collaboration. When something unexpected happens, when your plans don't work out, when reality surprises you, see it as an opportunity to learn and grow. See it as the universe presenting you with a puzzle to solve, a challenge to overcome, a story to tell. Because ultimately, the best stories, the ones we remember and retell and find meaning in, are the ones where the outcome was uncertain. If a story is predictable, it's boring. If you know the hero will win and the villain will lose and everything will work out perfectly, why bother watching? The tension, the drama, the emotional investment, all of that comes from not knowing what will happen next. Your life is a story you're living in real time, and the fact that you don't know how it will end is what makes it compelling. Every day is a new chapter. Every choice is a plot twist. Every challenge is an obstacle that the protagonist, you, must overcome. And the beauty is that you're both the author and the main character. You're writing the story as you live it, making choices that determine the narrative direction, creating meaning through your actions and relationships. 3I Atlas is a character in the universe's story, a wanderer whose arc intersects briefly with ours before diverging again into the unknown. We get to observe this character for a brief moment, learn from its journey, and incorporate its lessons into our own narratives. And then we continue our own journeys, carrying those lessons forward, becoming teachers for future observers who will watch their own interstellar visitors and extract their own meanings. This is the great chain of consciousness, stretching across time and space, linking all beings capable of wonder and understanding. You're part of that chain. The knowledge you've gained from learning about 3I Atlas will change you in subtle ways, affecting your choices and perspectives. And those changes will ripple forward, affecting everyone you interact with, who will in turn affect others, creating a cascade of influence that extends far beyond your individual lifespan. In a very real sense, by learning about 3I Atlas, by allowing yourself to feel wonder at this cosmic event, you're ensuring that the comet's influence will persist long after it's faded from view. The physical object will disappear, but its impact on human consciousness will remain, preserved in the collective memory of our civilization, passed down through generations as a story about the time we watched an interstellar visitor erupt chaotically and learned what that meant about the galaxy we inhabit. And centuries from now, when interstellar objects are common, when humanity has spread beyond Earth, when our descendants look back at this era, they'll remember 3I Atlas as one of the early visitors that helped shift human perspective from parochial to cosmic. They'll see it as a milestone in our species' maturation, a moment when we began to truly grasp our place in the galactic community. You're living through that moment right now. You're witnessing history, participating in a fundamental shift in human consciousness. That's not an exaggeration. The detection and study of interstellar objects is as significant as the Copernican revolution that displaced Earth from the center of the cosmos, or the discovery of deep time that revealed the Earth's ancient age, or the detection of exoplanets that proved other worlds exist. Each of these discoveries required humanity to let go of comforting illusions about our specialness and embrace uncomfortable truths about our actual place in reality. Each time, we resisted initially, then gradually accepted the new paradigm, and eventually wondered how we ever believed anything different. That's happening right now with interstellar objects. We're transitioning from seeing our solar system as isolated and special to recognizing it as just one of billions, constantly exchanging material with the wider galaxy, part of a cosmic ecosystem we're only beginning to understand. And you're here for it. You get to witness this transition, participate in it, help shape it by how you respond to these discoveries and what meaning you extract from them. That's a privilege and a responsibility, because the meaning we collectively assign to discoveries like 3I Atlas will determine how our civilization moves forward. Will we see it as proof that we're cosmically connected, inspiring us to think more expansively about our place in the universe? Or will we see it as just another scientific curiosity, interesting but ultimately irrelevant to daily life? The choice is ours, individually and collectively. And I'm arguing passionately for the first interpretation, because I believe it's more true and more useful. We are cosmically connected. The boundaries between here and there, between Earth and space, between our solar system and the galaxy, they're artificial constructs, useful for organization but not reflective of deeper reality. Matter and energy and information flow between stars. We're part of a galactic ecosystem, and recognizing the truth should fundamentally alter how we see ourselves and our responsibilities. If we're part of a galactic ecosystem, then we have obligations that extend beyond Earth. We have a responsibility to preserve and spread life, to contribute to the cosmic story in positive ways, to be good ancestors not just for future humans, but for future conscious beings of any kind. We become stewards of consciousness itself, recognizing it as rare and precious and worth protecting and propagating. This might sound grandiose, but it's the logical conclusion of taking the 3I Atlas discovery seriously. If interstellar objects can carry organic molecules between star systems, potentially seeding life, then life isn't confined to individual planets. It's a galactic phenomenon. And if life is galactic, then consciousness, which emerges from life under the right conditions, is also galactic. We're not alone, even if we haven't detected anyone else yet. We're part of something larger. And even if it turns out we are alone, that we're the only conscious beings in the observable universe, that doesn't diminish our significance. It increases it exponentially. Because then we're not just participants in the cosmic story. We're the authors. We're the universe's only way of knowing itself. All the responsibility for creating meaning and purpose falls on us. Either way, whether we're one of many conscious species or the only one, we matter. Our choices matter. How we respond to discoveries like 3I Atlas matters. Because we're shaping not just our own future, but the future of consciousness itself. So let me ask you one final question, and I want you to really think about your answer. What kind of ancestor do you want to be? Not just for your biological descendants, if you have any, but for all future conscious beings. What legacy do you want to leave? What stories do you want passed down about this era, about our species, about you? Because that's what it comes down to. You can't control whether you'll be remembered individually. Most of us won't be. But you can control whether your existence made the universe slightly better or slightly worse. You can control whether you contributed to the growth of knowledge and compassion and wonder, or whether you detracted from it. You can control whether you lived as a conscious, intentional being who extracted meaning from existence and left things better than you found them. 3I Atlas is doing that in its own unconscious way. It's contributing data to our knowledge base, inspiring wonder, connecting us to the wider universe. It's being a good cosmic citizen simply by existing and being observable. You can do the same, but with the added benefit of consciousness and intention. You can deliberately choose to be curious, compassionate, creative, and connected. You can choose to be the kind of being that makes consciousness seem like a good idea, the kind that justifies the universe's billions of years of work to produce you. That's my final message, the culmination of everything we've explored over these hours together. You're cosmically significant. You're part of a universe-spanning story. You're both infinitesimally small and infinitely important. And how you choose to live, how you respond to wonder, how you treat other conscious beings, how you engage with the mystery of existence, all of that matters more than you can possibly imagine. 3i Atlas will fade from view soon, disappearing back into the darkness between stars. But its impact will remain, preserved in scientific papers, in shifted perspectives, in renewed wonder at the cosmos. And you'll continue your own journey, carrying forward the lessons you've learned, the wonder you've felt, the expanded perspective you've gained. Thank you for taking this journey with me. Thank you for caring about an interstellar comet. Thank you for being the kind of person who watches a 3-hour-plus documentary about space instead of something easier and more immediately gratifying. The fact that you're here, reading these words, engaging with these ideas, that says something beautiful about you. It says you haven't lost your capacity for wonder. It says you're curious about your place in the cosmos. It says you're willing to sit with big questions and existential uncertainty. Those qualities, curiosity, wonder, courage in the face of uncertainty, they're what consciousness does best. They're what make you valuable beyond measure. And they're what will carry our species forward into whatever future awaits us. So keep looking up. Keep asking questions. Keep feeling wonder at the strange and beautiful universe we inhabit. And remember that every time you do, you're fulfilling the universe's purpose of knowing itself. You're not just a witness to the cosmic story. You're essential to it. Without consciousness, without beings like you who can observe and understand and care, the universe would be just matter and energy, sound and fury, signifying nothing. But with you, it becomes meaningful. With you, it becomes a story worth telling. And what a story it is. From the Big Bang to atoms to stars, to planets to life, to consciousness to you. Watching a comet from another star system erupt chaotically, and finding in that chaos profound lessons about existence itself. That's not just remarkable. That's miraculous. Thank you for being here. Thank you for being you. Thank you for letting 3i Atlas change your perspective even slightly. The universe is better because you're in it, paying attention, creating meaning, spreading wonder. Now go out there and live like the cosmic being you are. Make choices that matter. Create meaning wherever you go. Spread wonder and knowledge and compassion. Be a good ancestor. And never forget that you're made of stardust, conscious and temporary, and precious beyond measure, floating on a pale blue dot in an infinite cosmos that needs you to give it purpose. The chaos of 3i Atlas isn't just happening out there. It's happening in your neurons, in your synapses, in the quantum fluctuations that underlie your thoughts. Your chaos and order intertwined, destruction and creation balanced perfectly. A temporary pattern of matter that can contemplate its own existence and find that contemplation beautiful. That's the real miracle. Not comets or galaxies or black holes, as amazing as those are, but consciousness, but you. The universe spent billions of years creating you. Don't waste it. Use it. Live it fully. And when your journey ends, when you disperse back into the cosmic cycle, like 3i Atlas eventually will, make sure you've left ripples that will outlast you. Because in the end, that's what immortality really means. Not living forever as an individual, but creating impacts that persist, patterns that propagate, meaning that echoes forward through time. You can achieve that immortality. You already are achieving it with every choice, every interaction, every moment of wonder. So thank you again. From the bottom of my heart, from one conscious being to another, from one temporary pattern of matter to another, thank you for existing, for caring, for wondering, for being willing to spend hours contemplating an exploding comet and what it means for your place in the cosmos. That willingness, that curiosity, that wonder, That's what makes this whole cosmic experiment worthwhile. That's what makes consciousness valuable. That's what makes you, specifically you, matter in the grand scheme of things. Never forget that. No matter what challenges you face, no matter how small or insignificant you sometimes feel, remember, you're the universe experiencing itself. You're stardust contemplating stars. Your consciousness witnessing chaos and finding in it beauty and meaning.